Very good morning, students. Today we will learn the cardiac cycle. I am going to share the screen. Is it visible? It's okay. So today we shall learn cardiac cycle. Previously we are already learned different steps or different stages of cardiac cycle. As we know, in normal human adult, the rate of cardiac cycle or rate of heartbeat, they are about 75 times per minute. And if in 1 minute 75 beats takes place, then each beat will take, or each cycle will take 0.8 second. So let us see along with that also which are the events takes place in the cardiac cycle. This is the diagram which shows the events in the cardiac cycle. In previous lectures we are already learned the atrial systole followed by ventricular systole, and when ventricular systole takes place at the same time atrial diastole is there. This atrial systole is about 0.1 second, and thereafter 0.3 second ventricular systole is there. Thereafter entire heart, means auricles and ventricles, both the parts, means all the four chambers, they are enter in the state of diastolic phase. It is called as complete cardiac diastole. That all these details we learned in the previous lecture. So today we will learn events in the cardiac cycle. In that we will learn how that isovolumetric or isovolumic contraction is there, how that walls they get open and closed, which are responsible for producing sounds, and in entire cycle, if we study this cycle from ventricular systole or beginning of ventricular systole, then in entire cycle 4 different sounds has been produced, and that all this detail we will learn. We can start from this point, means from the isovolumetric relaxation, or you can start it from the atrial contraction also. So for your convenience or for your better understanding, we will learn it from the isovolumetric contraction, or it is also called as isovolumic contraction. This phase begins actually from the systole phase of ventricle. Let us see, this is the first step of isovolumetric or isovolumic contraction. In that, in response to the contraction of ventricular muscle, the pressure in the ventricles increases very rapidly. In both the ventricles, pressure increases very rapidly, but there is no change in the intraventricular volume, because both the auriculoventricular walls, they are closed. The increase in the pressure within the ventricles leads to the sudden closure of AV walls, and due to that sudden closing of these auriculoventricular walls, it is responsible for production of first sound, or it generates first sound. At the beginning of ventricular systole, ventricles contract as closed cavities without shortening of ventricular muscles, and it takes for about 0.05 second. Means immediately as soon as this process starts, at the same time sound will be never produced here, because it will take time to increase the pressure. Thereafter both the walls, both the AV walls, they will get closed, and it will take about 0.05 second time, and this period is called as isovolumetric contraction period. Then there is a second step, that is the ventricular ejection phase or rapid ejection phase. This phase follows immediately, during which the ventricular pressure reaches its maximum in both the compartments, in both the ventricles. When that pressure reaches its maximum and is greater than the aortic pressure, means both the aortas, both the aortic arches, in which whatever pressure is there, as compared to that, when pressure exceeds within the ventricles, so what will happen there? No doubt, therefore the semilunar holes open and blood is expelled from the left ventricle into the aortic arch. This is the left ventricle actually, so from which blood will enter into the aortic arch, and from the right ventricle blood will rushes into the pulmonary aorta. The rapid ejection phase is of 0.11 second. Blood spurts from heart with a peak flow of 5 to 10 times per mean flow rate. Then thereafter a reduced ejection phase is also there. Then what is the reduced ejection phase? Suppose that if both the ventricles they get contract very fastly, more and more pressure which has been exerted, and much of the blood, if it is get pushed into the both aortic arches, what will happen thereafter? Means it is just before the ventricular relaxation. Here there is a one more stage that is called as reduced ejection phase. During this phase, the contractile forces of heart decreases. So it is followed by decrease in the intraventricular pressure. This phase is of 0.14 सेकंड, म्हणजे जवळपास 0.14 सेकंदापर्यंत फक्त हा वेळ असतो. The aortic pressure is greater, but blood outflow continues due to the momentum of the flowing blood. So thereafter repolarization of the myocardium occurs during this phase also. Then here actually this is the end of systole. Here when it stops or when systole ends, what will happen thereafter? Here entire wall or myocardium of the ventricles, it is get relaxed. The end of systole is marked by the beginning of second heart sound. Listen me one more carefully important thing. When the end of systole, it will occur. The end of systole is marked by the beginning of the second heart sound. The contraction of muscles decreases very rapidly. There is a reversal of arterial blood flow towards the walls. This closes the semilunar wall of both the aortic arches. So this closes the semilunar walls, and because ventricular pressure drops so fast, the walls are tensed to such an extent that vibrations produced give the second sound. The here the three clear divisions are there, and these three clear divisions in the outer circle represent the ventricular diastole, in which it takes about 0.5 seconds. When the auricles are contracting, the ventricles are in diastole, receiving the last part of their feeling. So that is why the last one division of the ventricular diastole is overlapped by the atrial systole. So here by this way, Complete cardiac diastole takes place the first two division of ventricular diastole coincide with the auricular diastole. Thus, it is clear that the diastole of the ventricles and the auricles always partly overlap for a period of 0.4 second. And so this 0.4 second in which both the auricles and both the ventricles, they are found in the relaxed stage, and hence we call it as a complete cardiac diastole. The entire heart is relaxed stage here, and thereafter we will learn next important step, that is the isovolumetric relaxation, or you can say it is the isovolumic relaxation. Actually, what is this isovolumic relaxation or isovolumetric relaxation? Here, the ventricular diastole takes place. So, as soon as both the ventricles enter in the diastolic phase, means in early diastole, there is a quite difference in between the late diastole. Let us see here why it is called as isovolumetric relaxation phase. Actually, in this isovolumetric relaxation phase, a short interval of time, it is about 0.04 second, intervenes between the end of ventricular systole and diastole. This period is known as protodiastolic period. So, this is the time between the onset of diastole and the closure of semilunar hole in the aorta. The semilunar holes close only when the interventricular pressure falls below the intra-aortic pressure. So, in the isovolumetric relaxation phase, both the auriculoventricular walls are closed, and so as the ventricular pressure decreases, there is no change occur in the ventricular volume. AV walls do not open because the intraventricular pressure takes a little time to fall below the auricular pressure, which reaches to the maximum at this stage as blood does not enter the ventricles. There is no increase in the volume of ventricles. The isovolumetric relaxation phase, it takes about 0.08 second. 0.8 आणि 0.08 मध्ये फरक आहे, लक्षात घ्या. Means it's a very small time, a very little time in which this phase is there, and in this early relaxation phase, or you can say it is ventricular relaxation early phase, it is also called as rapid filling phase. In this phase, what happened thereafter? The rapid filling phase is a period during which the ventricles are filled very rapidly. The pressure in the ventricles at this stage is less than in atria, so that the AV valves opens and blood rushes into the ventricles. The first part of this filling of the blood, a sound it produces, and it is the third sound of heart. So here actually what happened, here these both the valves they get open, and hence rapidly blood enters into the ventricles. Hence it is called as a rapid filling phase. Actually this is the late phase. Here I missed one diagram. It is in between the, this one means ventricular diastole, early ventricular diastole, and thereafter after this sketch, after this isovolumetric relaxation phase, there should have one more sketch, one more diagram in which both the walls of the atria, they get open, and in that situation rapidly blood enters into the ventricles. It is called as a rapid filling phase, and thereafter this is the actually late phase of ventricular diastole. It is called as reduced filling phase. As the ventricle feels the ventricular compliance act to develop, more and more back forces to slow the feeling. As we know, whenever these both bags, both compartments, it will get filled with blood naturally. When it is get full of blood, then flow of blood which enters from atria to ventricles, it will slow down. Further, the ventricles are already filled at this stage, and intraventricular pressure increases to slow down the rate of inflow from the auricles, and this period lasting for about 0.167 सेकंद, म्हणजे 0.167 सेकंद, म्हणजे ऍक्च्युली 1.5 सेकंदापेक्षा जरा जास्त वेळ लागतो. सॉरी, 0.1 म्हणजे 0.167 एवढाच त्याचा पिरियड आहे. किंवा त्याला लक्षात ठेवायला हा आकडा कठीण जात असेल तर 0.16 एवढाच लक्षात ठेवा, 0.16. And this is known as diastasis, or it is also called as reduced filling phase. This is the longest period of ventricular diastole actually, and thereafter next phase occurs, and you know very well which will be the next phase. Here thereafter both the atria, it will get contract, and we call it as a atrial systole. So in this atrial systole or atrial contraction, after this period, it is the last part of the ventricular diastole which coinciding with the atrial systole of 0.1 second. Due to atrial contraction, blood again rapidly enters into both the ventricles. So again, due to the atrial contraction, blood again rapidly rushes into the ventricles and producing a fourth sound, and this period is known as last rapid filling stage. The fourth sound demarcates the end of ventricular diastole. So by this way, here we studied entire cardiac cycle, and in that different events was there. We learned that all these events of cardiac cycle. Now let us see where are these different sounds they were produced at the time of cardiac cycle. As we know, we started this cycle from isovolumetric contraction. When isovolumetric contraction takes place, means when ventricular systole is there, first sound has been created due to the closure of AV valves, right? Thereafter, when this ventricular ejection or ventricular systole has been completed, means just the beginning of ventricular diastole, there is a second sound has been produced. Thereafter, third sound is produced at the ventricular filling phase, and fourth sound has been created when there is a atrial contraction. So by that way, here entire cardiac cycle which is responsible for producing these sounds